Hey everyone, in this video we're going to learn how to graph quadratic functions with irrational roots. Our approach will be similar to graphing quadratic functions in standard form, with the main difference coming in finding the x-intercepts. Since we have irrational roots, we are going to have to use the quadratic formula. So the directions state to graph the following quadratic function by including at least 3 points and estimating the location of the irrational roots. Determine the domain and range. So we're still defining our parabolic curves with 5 points, just 3 well-defined points and 2 estimated based off the irrational roots. Our first function is f of x equals x squared minus 8. So we'll start by finding the y-intercept. So that occurs when x equals 0. So we have 0 squared minus 8. So f of 0 is going to be negative 8. So the y-intercept is 0, negative 8. We're going to hold off on the x-intercepts. Instead, we'll start by finding the axis of symmetry. Since it's in standard form, we'll use x equals negative b over 2a. So we have x equals, b is 0 because there is no x term, so we have negative 0. Negative 0, that's better, over 2 times 1. So we have x equals 0 as the axis of symmetry, which means our vertex is the point 0, negative 8, which is the y-intercept. So we did that work and we wound up with the same point, but at least we know that the vertex and the y-intercept are the same. Now we're going to find the x-intercepts. So we have x squared minus 8 equals 0. Since we cannot factor this quadratic equation, we're going to have to solve it with the quadratic formula. So a is 1, b is 0, c is negative 8, and we need to find the discriminant. So I'll do that over here. Remember, the discriminant is b squared minus 4ac. So we have 0 squared minus 4 times 1 times negative 8, which is going to be positive 32. So quadratic formula, x equals negative b plus or minus the square root of the discriminant, which is 32, all over 2a, so 2 times 1. Square root of 32 can be simplified into the square root of 16 and the square root of 2, which is 4 square root of 2. So we have x equals 0 plus or minus 4 times the square root of 2 over 2, which is plus or minus 4 square root of 2 over 2. So that means x equals plus or minus 2 times the square root of 2. So our x-intercepts are 2 square root of 2 comma 0 and negative 2 square root of 2 comma 0. So let's plot the points that we found so far. So we have 0, negative 8 as both the y-intercept and the vertex. Now we need to estimate where 2 square root of 2 is. So square root of 2 is 1.41 approximately. So if we double that, we get 2.8 about. So positive 2.8 would be about there, and negative 2.8 would be about there. If we weren't sure, we can go to our calculator. 2 times the square root of 2, and we have approximately 2.8. Now that's only 3 points, and we need 2 more to define our parabolic curve. So we can plug in x equals 2. So if we do that, f of 2 is going to be 2 squared, let's make that a little bit neater, 2 squared minus 8. So f of 2 is 4 minus 8, which is negative 4. So 2, negative 4 is a point on our curve. 1, 2, 3, 4. Now by symmetry, axis of symmetry is x equals 0. So that points 2 to the right, so we'll go 2 to the left. So the point -2, -4 is also on our curve. So we have 5 points. So we can draw our parabolic curve. And lastly, the domain is all reals. And the range is any y value greater than or equal to -8. So we'll go bracket -8 to infinity. Okay, so there's our first example. The biggest difference is how we find the x-intercepts. We had to use the quadratic formula. Everything else is pretty consistent with how we've been finding it in the previous 2 videos. Same directions. The next function is f of x equals -x squared plus 6x minus 6. So we'll start with the y-intercept. So f of 0 is -0 squared plus 6 times 0 minus 6. So f of 0 is -6. So 0, -6 is our y-intercept. Now we need to find our axis of symmetry. So x equals -b, so b is 6, so -6, over 2 times a, which is -1. So we have -6 over -2. So we have x equals 3. So our vertex is the point 3, comma, we'll substitute 3 in for x. So -3 squared plus 6 times 3 minus 6. So f of 3 is -9 plus 18 minus 6. So that's 9 minus 6, which is 3. So 3, 3 is our vertex. Now we need those x-intercepts. So x-intercepts, we're going to set -x squared plus 6x minus 6 equals 0. Quadratic formula, so we have a equals -1, b equals 6, c equals -6, and we need our discriminant. So b squared minus 4ac, so that's going to be 6 squared minus 4 times -1 times -6. So we have 36 minus 24, which is equal to not 8, it's equal to 12. So now we use the quadratic formula, so x equals -b plus or minus the square root of the discriminant, which is 12, over 2a, so 2 times -1. Square root of 12 can be simplified to be the square root of 4 times the square root of 3, which is 2 times the square root of 3. So we have x equals -6 plus or minus 2 times the square root of 3 over -2. We can factor out a -2 from the numerator. So that would leave me with positive 3. Positive 3. Now if we factor out a negative from a plus or minus, it would stay plus or minus. And then we'd have rad 3 over -2. So -2 and -2 simplify. So we have x equals 3 plus or minus the square root of 3. If you didn't factor out the negative, you would have -3 plus or minus rad 3 over -1, which is equivalent to what we have here. So our x-intercepts are 3 plus the square root of 3 comma 0, and 3 minus the square root of 3 over 0. Now we have all of our points, and we have to plot them. So we'll start with the y-intercept. So 0, negative 6, 1, 2, 3, 4, 5, 6. The vertex is at 3, 3. So now if we look at our x-intercepts, well, the axis of symmetry was x equals 3, and look at these, it's 3 plus the square root of 3 and 3 minus the square root of 3. So they're based off of the axis of symmetry, which is really nice. So one x-intercept is rad 3 to the right, one x-intercept is rad 3 to the left. Rad 3 is about 1.7, so 3 plus 1.7 would be 4.7. So we're at 3, 4.7. And then I'll use the calculator to show you 3 minus rad 3. So let's say we weren't sure what that would be approximately. So 3 minus the square root of 3. Can enter, and we'd have approximately 1.3. So we're estimating, so 1.3 would be about there. Now the axis of symmetry is x equals 3. The y-intercept is at 0, negative 6, so 3 to the left of the axis of symmetry. So we'll go 3 to the right. So we'll be at 6. 1, 2, 3, 4, 5, 6. Negative 6. Now we have 5 points. And we can sketch our parabolic curve. So the domain is negative infinity to infinity, all reals. And the range is any y value less than or equal to 3. So in interval notation, that would be negative infinity to 3 with a bracket. Okay, that one took a little bit more time. Quadratic formula was a little bit more involved. But nonetheless, we go through the same process, find all of our points, and create our curve. Same directions, next equation, y equals 2x squared plus 4x minus 3. Again, we're starting with that y-intercept. So x is 0 minus 3. So y equals 0 plus 0 minus 3, which is negative 3. So we have 0, negative 3. Find the axis of symmetry next. So x equals negative b, so that's negative 4 over 2a, which is 2 times 2. So that's negative 4 over 4. So we have x equals negative 1. So our vertex is the point with an x value of negative 1. To find the y value, we're going to plug in. So we have 2 times negative 1 squared plus 4 times negative 1 minus 3. So we have y equals 2 times positive 1 minus 4 minus 3. So that's 2 minus 4 is negative 2. Minus 3 is negative 5. So negative 1, negative 5. And now we're at the x-intercepts. So we set 2x squared plus 4x minus 3 equal to 0. It's helpful that we already know that these roots are irrational, so we don't even have to check if we can factor this. We know going into the problem that we can't. If we weren't sure, we would find the discriminant anyway, and then we'd be set up to use the quadratic formula. So we have a equals 2, b equals 4, c equals negative 3. We need that discriminant, as I was just talking about. So that discriminant is 4 squared minus 4 times 2 times negative 3. So 16 plus 24. 4 times 2 is 8, times 3 is 24. The two negatives become a positive. So that gives us 40. And as a reminder, that's not a perfect square. And as I was speaking about, that tells us we can't factor. Using the quadratic formula, x equals negative b plus or minus the square root of the discriminant all over 2a. Square root of 40, we can simplify to be the square root of 4 times the square root of 10, which is 2 times the square root of 10. So we have x equals negative 4 plus or minus 2 square root of 10 all over 4. We can factor out a 2 in the numerator. That would be negative 2 plus or minus the square root of 10 over 4. The 2 and the 4 simplify. So that means our x-intercepts are at negative 2 plus the square root of 10 all over 2 comma 0. And negative 2 minus the square root of 10 over 2 comma 0. Now these are going to be a little bit tougher to estimate by thinking, so we're definitely going to have to use the calculator here. So let's estimate those before we start graphing. So let's do the numerator first. So negative 10 plus, negative 2 rather, plus the square root of 10 equals 1.16, repeating. Divide by 2, and we have 0.58 approximately. So we'll estimate this one at 0.6 comma 0. I'll draw squiggly equals so we know it's approximately. And then we'll do minus 2 or negative 2 minus the square root of 10. And that's negative 5.16, etc. Divide by 2. And we have negative 2.58. So we'll estimate that to be negative 2.6 comma 0. Approximately. Okay, so now we have all our points to create our graph. So we have the y-intercept at 0, negative 3, the vertex at negative 1, negative 5. One of the x-intercepts is 0.6, so a little bit past 1/2. And the other x-intercept is at negative 2.6. So negative 2.6. That's 4 points. We need a fifth. So the axis of symmetry is x equals negative 1. The y-intercept is 1 to the right, so we'll go 1 to the left. The point negative 2, negative 3 is also on our curve. And we can connect our points to create our graph. Domain is all reals. And the range is any y value greater than or equal to negative 5. So we're going negative 5 to infinity. On to our next example. The function is y equals negative 1/2 x squared plus x plus 3. So again, we're going to start with that y-intercept. So y equals negative 1/2 times 0 squared plus 0 plus 3. So we have 0 plus 0 plus 3. We get y equals 3. So 0, 3. Next up, we'll find that axis of symmetry. So x equals negative b, so in this case that's negative 1, over 2a. A is negative 1/2. So that's going to be x equals negative 1 over negative 1, which is x equals positive 1. So our vertex, x value of 1, we're going to input that into our equation. So negative 1/2 times 1 squared plus 1 plus 3. So we have y equals 1 squared is 1 times negative 1/2. So we have negative 1/2 plus 1 plus 3. So that's going to be negative 1/2 plus 4, which common denominator, negative 1/2 plus 8 over 2 is 7 over 2. So our vertex is 7 over 2, or 1 comma 7 over 2. Okay, now onto those x-intercepts. We're going to set negative 1/2 x squared plus x plus 3 equal to 0. And we're going to use the quadratic formula. So a equals negative 1/2, b equals 1, c equals 3. And we need to find that discriminant. So b squared, 1 squared, minus 4. A is negative 1/2, c is 3. So we get 1 plus, negative times a negative. 4 times a half is 2, times 3 is 6, so we get 7. So quadratic formula, x equals negative b, so negative 1, plus or minus the square root of 7 over 2 times negative 1/2. So that's x equals negative 1 plus or minus the square root of 7 over negative 1. Now we can factor out a negative 1 in the numerator so that it simplifies with that denominator, and that would leave us with positive 1, still plus or minus. Technically it would be minus plus, but we don't have to change how it looks, right? Because the positive would become negative, the negative would become positive, so minus plus plus minus. Divide by negative 1. Negative 1 simplify. So that means our x-intercepts are 1 plus the square root of 7, 0, and 1 minus the square root of 7, 0. Now again, before we start graphing, let's approximate where these are with the calculator. So 1 plus the square root of 7. That's about 3.6. So 3.6, 0, approximately again. And then 1 minus the square root of 7 is approximately negative 1.6. Okay, so we have all the points that we found. So we have 0, 3, 1, 7 over 2, so that's 3.5, about. Then we have those x-intercepts, so 3.6 and negative 1.6. So 3.6 is about there, negative 1.6 is about there. We need one last point. So looking at the y-intercept, it's 1 to the left of the axes of symmetry. So we'll go 1 to the right. So the point 2, 3 is also on our parabolic curve. And we'll connect our points to create our parabola. And then answering those last two questions, domain is all reals. And the range is any y value less than or equal to 7 over 2. So in interval notation, that's negative infinity to 7 over 2 with a bracket. Now we have one last question to answer. If one x-intercept of a quadratic function is 4 minus 3 times the square root of 6 over 5, 0, what is the other x-intercept? So in order for the person to find 4 minus 3 times the square root of 6 over 5, 0 as one of the x-intercepts, they had to use the quadratic formula. You wouldn't get this solution from factoring. So if we recall, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We've been using that throughout this video. The solution they gave us was negative b minus the square root of the discriminant over 2a. So the other x-intercept would be found by negative b plus the square root of the discriminant over 2a. So we can take the solution they found and change the negative to a positive, so 4 plus 3 rad 6 over 5, 0, and that would be the other x-intercept, the conjugate of the x-intercept that they found. So at this point, let's recap graphing a quadratic function with irrational roots. The main difference is when finding those x-intercepts, we have to use the quadratic formula. We don't have to simplify the quadratic formula in this case if we're estimating. We can just plug it in and go directly to our calculator, but it's good practice to simplify the quadratic formula as much as possible, right? Simplify the square root and then simplify any further if we could. Easier to plug into the calculator and good practice for more general questions that aren't referring to graphing, where we're estimating the values. From there, find the y-intercepts, the axis of symmetry, the vertex. As long as we have those 5 points, we can then graph our parabolic curve. So at this point, the only thing left to do is for you to go try a few on your own so that you feel confident in graphing these types of quadratic functions. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.